So now what? Are you as discouraged as I am? How can people responsible for making sure that something terrible isn't happening again refuse to take a few tests? And why don't the people there hire somebody to take the tests? A few of them have, and they have found higher levels. Is it true that what you don't know can't hurt you? If you lived across the street from the Love Canal, would you be taking your own samples, or would you be trusting the government and the individual corporations? You probably have heard me speak about Hurricane Katrina. My house was, the second house off of the beach from the Gulf of Mexico before Hurricane Katrina. I built it with a crew. I worked on all aspects of it. I spent a couple of years doing nothing but building that house. I wanted to learn how to build houses, but I also just wanted to build one for myself. Had a great time, learned enormous things. Point is, I was very invested in this house. When it gets to a point where it needs to be insured, I call my insurance company. My guy walks out. We know each other well. And he says, now, you're not in a floodplain, so you don't need flood insurance. I looked at him. I looked at the Gulf of Mexico. I looked back at him, and I said, what do you mean I don't need flood insurance? He said, you're not in a floodplain, so you don't need flood insurance. I said, put me down for flood insurance, because that Gulf of Mexico is going to rear its head at some point in time, and my house is going to be directly in the way. I got 1 year in that house before I lost it. Still breaks my heart. So, do you trust these institutions? Ethically, should you trust the institutions? They have ethical responsibilities. Ethically, in my opinion, they should continue testing, not just the part they put in to make sure it's working, but the part that they haven't checked to make sure that their test methodology is working. They are consistently testing what they've been told to test. What they are not testing is the testing methodology. And it's over 50 years old. And it was one of the first methodologies put together for one of the first documented environmental disasters. What do you guys think? Is it time to update those testing methodologies? Is it time to test the test? As time goes on, our skill sets and our knowledge improve. We have an awfully lot of people doing research these days, and they're doing a good job. When you write programs, you will have a given technology, a state of the art, that will change over time. But the project you write will kind of be fixed in time once you walk away. Not too many people will alter it. What is your ethical responsibility? Your projects that are fixed in time need to be coded so that it's easy to go back and recheck and to recheck the testing. So that if there is an upgrade or a fix that needs to be done, you have handed it off to somebody in a way that they can more easily manipulate it. That's our ethical responsibility as programmers. We don't just write the code, we design it in such a way that it's easy to use in the future. This is the field of software engineering. This field studies how to write code and how to write code that is maintainable. There are two different aspects. It is our ethical responsibility to create a project design that is fixable and upgradable. We currently have the following ideas on how to do that. These ideas will change as well. How are you going to keep up with your ethical responsibility to produce the most forward-looking code you can? First, and it's fun, you have to keep up to date, not just with the current technologies, but also with the forecast developments over hopefully the next decade. You have to be paying attention to the field. You don't just go in, write your programs, and go home. You read magazines about how computer science is moving forward. You read research papers. You keep up, however it takes, with that field. Now, there are practical reasons to do this as well. My son went to a private school. I live in South Mississippi, and our school districts are rated very, very low. I live by one of the most highest ranked high schools, but I still didn't trust the school system. We were really at the bottom. Now California is below us in some standards, which makes us feel good, except I think it just means California's gotten even worse. So anyways, my son is in this private school with lots of other families, and one of the other parents is a programmer. He's a specific programmer. He's worked only with a particular IBM database his entire life. It was a very lucrative career, paid lots of money. We're both in our 40s, and he loses his job because that system gets upgraded. He did not take any time to keep up with the field. He didn't learn Java, he didn't learn C++, he didn't learn object-oriented programming, he didn't learn any of these things. Because he had a great job and he was happy with it, and he knew one thing and he could market that one thing. He now lives in the Middle East, working for a company that still uses that database. He's been separated from his family and only gets back to the United States every couple months because he did not keep up to date. So not only is it our ethical responsibility so that we can design better software for the future, but it's also a practical obligation so that we can keep on making a living. So that's why and how we pay attention. But for right now, what we do is write modular code. Modular code does not mean one page long. It means the code is cohesive and not coupled. I didn't say it's object-oriented. Both procedural and object-oriented have their place in computer science, and they both need to be cohesive and non-coupled. You can write OOP that is so coupled it'll turn your eyeballs around. You need to make sure that both the objects that you're writing and the procedural code that you're writing are cohesive and not coupled. Let me quickly define it in a simple way. Coupled code would be passing a lot of parameters. So if you're passing a whole lot of parameters to routines, or an OOP, if you're inheriting from if your inheritance path is long in OOP, or if you're passing lots of parameters in procedural, your code is coupled. It's not well designed. You want to write modules that need the barest information passed to them. Cohesive means that they do one and only one thing. So if your code is being passed any kind of a flag at all that says do this on this circumstance, you probably should examine it to see whether or not you can break it into more cohesive pieces. When you write modular code, It's much easier to test, much easier to produce an API from, much easier to use. I know that almost the only thing you're taught is OOP, and you think everything should be OOP. Please understand that procedural is also very important. The next thing you need to do is produce useful documentation. I didn't say a lot of documentation. I said useful documentation. You should always have a README file. You should always have a README file, even if it's not needed, just so that the person who's using your code sees it and thinks, ah, they're thinking about me. How kind. So it's more like saying hello when you pass someone in the hallway. You should have a README file because you're passing the information on to the next person and you're letting them know that you did it. You can walk by someone in the hall and think, oh, it's delightful to see them, but not say hi. And they don't know it was delightful to see them. So just the act of producing a README file is going to help them to see that you were thinking about the future needs. A lot of documentation will hurt you. I'm working on a project right now, and a survey was passed around to collect a bunch of information from previous hurricanes. It's a hurricane project. And one of the questions was, does sufficient documentation exist? And one guy replied, there is so much documentation that you need documentation on the documentation on the documentation. You don't need too much documentation. Then it's useless because you can't find the needed information. You need to think about what people will need to know and then point them that direction so that you've anticipated what their needs will be in the future and how they will go about changing your code to meet those needs. I'll go to one more detail. My son, you guys know, just finished his degree a year ago. He was at the University of Rochester. They have a very good computer science program, but there were a couple things I didn't like about it. This one has nothing to do with computer science, but they did not require physics, which breaks my heart. You just can't understand the hardware without the physics. But anyways, he got done. He's a very good Java programmer, a very good OOP designer. I have no issues with how he inherits. It's not a big long line. He does everything mostly well. He doesn't think about cohesiveness. He thinks I'll write an object to do this. And he doesn't think about those methods maybe being too complex and broken down. More important, he doesn't think like a software engineer. So probably when you get out, you won't either. That's why I'm just taking the time to mention this. I had the opportunity to work on this hurricane project, and I hired him to do my Java code. Now, I could have done the Java code. It would have taken me longer, and I wouldn't have been able to do as much interesting science. But I wanted to be able to work with him to show him how you redesign things. We started with a database for something. He was happy with the design. He would have lived with it. I then went back, changed it to third order, brought it back to him. He looked at it and he said, wow, this is so much better. He hadn't taken a database class where he learned the normal forms, nor had he learned the reasons for the normal forms. So software engineering incorporates the information you've already learned about computer science into a way that you can apply that to build better code. That takes a long time to learn, but the people who learn it are the people who are paying attention and asking these questions each time, and then assimilating what they learn. So I'm begging you to become the person who's paying attention to the future and whether or not you've written a nicely separated code.